Okay, in lesson 10, we're going to look at adverse selection. In this problem, a major health insurance company has hired you to provide it with economic consulting to analyze the health insurance market in Caucasia, a fictional country.
Mhm.
Your analysis and research have found that there are generally 39,000 high-risk Caucasians and 56,000 low-risk Caucasians. Now, a high-risk Caucasian could be well, it can be a group of people that tend to use lots of healthcare services. A low risk Caucasian can be a group of people that on average don't use healthcare services. So one way you could look at high risk Caucasians is you could say, well, maybe women are high risk Caucasians because women on average tend to use healthcare services at a higher rate than men. Or you could think of the high risk group as older Caucasians and the low risk as younger. It could also be a group of people who are more likely to have a higher probability, a genetic predisposition to cancer. They would be high risk Caucasians. So there's a lot of ways that we're going to be able to analyze real world situations using this generic model. Now, the yearly earnings of the average Caucasian in my version of the model is $80,875. And the average cost of medical treatments in my model, in my version of it, is 18,807 per Caucasian. The earnings is variable W. The medical treatment cost is the variable C. And then we have the probabilities of needing medical procedures for high risk and low risk Caucasians. And in my model, the probability of a low risk Caucasian needing a medical procedure is 10%. And the probability of a high risk Caucasian needing a procedure is 17%. We're going to use these above numbers to first calculate the expected income of Caucasians who purchase health insurance. We're going to use this formula here to do that. So what I'm going to do is I'm going to open up Desmos. You can do this in Excel if you want. I like Desmos. You can use it as a graphing tool, or you can just use it as a calculator, or you can use it as a place to store your work. I'm logged in using my Gmail account, and then I can actually save this. I can actually save this as Health Econ Lesson 10. And this could be my work, right? So if there was going to be a test in this class, I could actually show my work in Desmos. And that way, when I go back and study, I could open up the Desmos and review my steps. And if I include all steps in my work, then it's much easier to study for the test. You don't have to spend your time trying to figure out how to solve it over again. All you have to do is review your steps, right? And I'm going to widen this out because it's going to be my work rather than a graph. Okay, so what I'm going to do is I'm going to type expected. I'm going to leave out the W because if I write EW, Desmos is thinking that I'm multiplying E times W. So I'm going to leave it as E. And then I'm going to write 1 minus P times capital W plus P minus C. I've written out this equation. Now what I'm going to do is I'm going to move this down, add some rows. I'm going to type what P equals 0.1. W in my model is going to be equal to 80,875. And then the cost of medical treatment in Caucasia, and in my model, it's 18,807. And then down here is my equation, right, that I typed in earlier. And notice what it does. It automatically substitutes these values into this formula and gives me what it equals. When the probability of a low risk Caucasian needing the medical procedure is 10%, the expected income of a Caucasian, a low risk Caucasian, that's equal to that amount. Double click on the number. I'm going to press Control C for copy. Then over here, I'm going to press Control V for paste. I'll check my answer. It looks like I got it right. Now to calculate the other one, all I have to do is change the probability of needing the medical procedure from 10 for low risk Caucasians to 17 for high risk Caucasians. And so their expected income is lower. Again, I'm going to press Control C after I double copy the value. It's lower because they have a higher probability of needing the procedure, the medical treatment. So this value right here, when this value is higher, this value is lower. So this value has less weight than this difference. I'll press enter and I should get both of them correct. Now, if insurance companies are free to charge Caucasians different premiums based on their known health status, the following can be used to calculate the actuarially fair health insurance premium. And we did this in the previous lesson. So here I'm going to type H for actuarially fair health insurance premium. And I think what I'll do is I'm just going to copy this again. This is 1 minus P. 1 minus P is the probability of not needing the procedure. If you don't need the procedure, you're not spending money on the procedure. This is the probability of needing the procedure. If you need the procedure, you're going to have to pay C dollars, that amount of money. So the actuarially fair insurance premium in my model with these things plugged in is $3,197.19. So this probability here is the high risk. So this is the high risk premium. So that would go right here in the second box. To get the annual cost of the low risk person's health insurance premium, we got to change the probability back to 10%. And so low risk Caucasians have a actuarially fair insurance premium equal to $1,880.70. The expected income of Caucasians who purchase health insurance is computed as follows. This right here stands for the expected value. It's like an average. The parentheses indicate the word of. So this is the expected value of what your earnings are given that you've purchased actuarially fair health insurance. If you've purchased the actuarially fair health insurance, this is the probability of not needing the medical treatment. This is the probability of needing the medical treatment. This is different than this because here, this is the expected income of somebody who's going to pay for the medical treatment out of pocket. But down here, these two things are the same, except the person has purchased 100% actuarially fair health insurance. In this health insurance, there's no deductible. There's no co-insurance because the health insurance company is going to pay 100% of the cost. So in the situation where we don't need the medical treatment, we have earned that amount and we have paid that amount in health insurance premiums. In the situation where we need the treatment, again, we're earning this and we're paying that. So these two things are similar, but here the cost of the procedure is being paid directly by the health insurance company. So whether or not we need the medical treatment, we have to pay the health insurance premium. Up here, we're paying the cost of the medical treatment out of pocket. Here we're uninsured. So this is the expected earnings of somebody who's uninsured. And this is the expected earnings of somebody who is insured. So what I'm going to do here is I'm going to copy this. I'm going to paste it in line 6. And then I need to change this to W minus our health insurance premium. And I need to change this to W minus H, which is our health insurance premium. I need to denote this maybe as subscript 1, and this is subscript 0. So this is the expected value of somebody who's uninsured, and this is the expected value of earnings for somebody who is insured. So in a month where they paid the premium and they got their earnings, if they don't need the procedure, they net W minus H. In a month where they need the procedure, again, they're not paying the cost. They're paying an insurance premium each month. Earnings net of the insurance premium is just W minus H. And notice that it's equal to the expected earnings of somebody who's uninsured. This is the probability of a low risk Caucasian. So this right here is the expected income of Caucasians who are low risk, given they've purchased health insurance. Now, if I change the probability to 17%, I get the expected value of earnings of a high risk Caucasian, given that person has purchased insurance. Control C, Control V. These two numbers are equal to these two numbers respectively, right? So this is kind of proof that these premiums are actuarially fair health insurance premiums. Now, suppose out of fairness, the government makes it illegal for insurance companies to charge different premiums to different Caucasians. Now, why might it do that? Well, maybe older people who are paying this premium find out that younger people are paying that premium, and they claim that it's unfair because it's only fair that these two things be identical. So maybe they're successfully lobbying their senators, their congresspeople, to institute a law that requires these two things to be the same out of fairness. Or maybe high-risk people are females and low-risk people are males, and females are outraged that their premiums are not quite double that of males. If males were charged a higher premium than females, would females argue that these premiums should be the same? I suspect not. If younger people, because maybe they live really reckless lives, they're jumping off bridges with bungee cords and they have this really high probability of getting hurt. If younger people were paying higher insurance premiums than older people, would older people be advocating for equalization of premiums? If you're the one paying the higher premium, of course, you're going to agitate. You're going to demand that the government make these premiums equal. However, I mean, it sounds great if you're the one that gets your premium lowered, but there are consequences. And economics, one of the jobs of economics is to understand the consequences of government policy. So let's just suppose that out of fairness, the government makes it illegal for insurance companies to charge different premiums to different Caucasians. The number of Caucasians who are expected to need medical procedures, what? Okay, so we need to multiply P times what? P.17 is the probability of a high-risk Caucasian. We need to multiply that by the population of high-risk Caucasians. The number of high-risk Caucasians is 39,000 in my model. I'm going to add a row here. I'm going to type N equal to 39,000. So this is the probability of a high-risk Caucasian needing a medical procedure. This is the number of high-risk Caucasians. So this times that is equal to what? 6,630. That's the number of people we expect to need this procedure. So I'm going to add two rows here. I'm going to type Q. Q is going to be the probability of a low-risk Caucasian needing the procedure. And then M will be the number of low-risk Caucasians. And the number of low-risk Caucasians is 56,000. So this is PL. And this is the number of low-risk Caucasians. This is the PH, the probability that a high-risk Caucasian needs the procedure. And this is the number of high-risk Caucasians, 39,000. What I'm going to do here is I'm going to add Q times M. So this number here is the number of Caucasians that we expect will need the medical procedure. So this is 12,230. Press enter to find out if this is the correct answer. It is. What is the number of Caucasians who are not expected to need a medical procedure? Well, N plus M is the number of Caucasians. It's a small country of 95,000 people. So it's the number of people in Caucasia who are high risk and low risk. Some of them may need the procedure. Some of them may not need the procedure. So there's 95,000 of them. So what I can do here is I can subtract off this amount. Total number of people, whether they need the procedure or not, and we'll subtract off the 12,230. So this is the number, I'm going to move this up. This is the number of people in Caucasia we expect to need the medical procedure. And this is the number in Caucasia we don't expect to need the procedure. This is the pooled probability because we've pooled high-risk people and low-risk people in the same swimming pool. We've asked all these people to jump in the swimming pool, and we've asked all these people to jump in that same swimming pool. And how many people are in the swimming pool now? 95,000. So what I'm asking for here is the pooled probability. And the pooled probability of needing the hospital care is the 12,230 divided by the 95,000 people who live in Caucasia. Rounded to what? 4 decimal places. So I go out to the fourth decimal place. The number in the fifth place is 3. So that means 7 remains 7. If this were 5, 6, 7, 8, or 9, then we'd round that to 8. But this is 4 or less. So we're just going to delete all of this out here. I'll press enter to make sure I got it right. What is the actuarially fair health insurance premium that is offered to all? Okay, so now we got to go back and get the actuarially fair health insurance premium. Okay, what I'll do is I'll denote the pooled proportion where low risk and high risk people are all in the same pool. I'll denote that as capital P. And then down here, I got 1 minus capital P times 0 plus capital P times C. So the actuarially fair health insurance premium that is offered to all equals $2,420.46 per year. Now, since this premium results in what? What's going to happen here? Low risk people are willing to pay that amount. They're willing to pay up to that amount. They're not willing to pay more than that amount. So this results in 0 low risk Caucasians choosing insurance because this premium is too high for them. Meanwhile, because this premium is the maximum premium a high risk person is willing to pay, exceeds this pooled premium, every one of 39,000 high risk Caucasians will be insured. Because all low risk people dropped out of the insurance pool, it leaves only the 39,000 high risk Caucasians being in the insurance pool. If all the low risk people drop out because the pooled insurance premium is too high for them, that means only high risk people are going to be in there, which means the pooled probability of needing the medical treatment is 17%. Now we want to calculate the expected annual profit on each insurance policy. Law says this is the insurance premium. Market says this is the percent of people needing the medical procedure. So now we're going to calculate the expected profit with that premium and this proportion of people needing the procedure. So we'll come down to line 15 here. I'll call this, I don't know, E subscript 2. I got 1 minus the probability. Let's go back up here. This is the probability of a high risk Caucasian needing the medical procedure. So I'm going to use little p here, times the health insurance premium, which is this number here, rounded 2 decimal places. So I'm using the health insurance premium that we calculated here. The 1 minus p is the probability of the high risk Caucasian not needing the procedure. So if the procedure is not needed for a high risk person, and remember, only high risk people are left in the pool, then the insurance company collects this from that person and pays out 0 for the cost of treatment because this is the probability of not needing the procedure. Now I'll copy this and I'll add it to here. I'll change this to just P. This is that insurance premium, right? Where everybody's pooled together and they got to subtract off the cost. So this is the probability of needing the procedure. So for somebody who needs the procedure, the insurance company is collecting that from them and they're paying that out. So notice the expected profit is a negative 776.73. If each policy is losing the insurance company money, the insurance company will go out of business and nobody will be able to insure. So that'll result in 0 Caucasians being insured. To avoid this consequence, suppose the Caucasian government mandates that insurance companies cover pre-existing conditions and imposes a penalty on citizens who do not purchase insurance. If the penalty is an income tax fine of $480, low-risk Caucasians will do what? Well, they can pay the $480 or they can pay this pooled premium. Now, to them, this is too much because the most they're willing to pay for insurance is that amount. So because pre-existing conditions must be covered by the health insurance companies, what the low-risk Caucasian will do is not insure. They'll pay the penalty of $480 to avoid paying the premium they consider to be too high. They'll not insure. If for some reason during the course of the year, a low-risk Caucasian needs the medical procedure, what that person can do is enroll in the insurance and pay this premium to avoid paying that cost. So under this policy, zero low risk Caucasians will buy health insurance. Now, because this premium is seen as a good deal for high risk Caucasians, they're going to insure. And there are 39,000 high risk Caucasians, and all of them will insure because, again, they see this as a good deal. It's lower than what their maximum willingness to pay is equal to, $3,197.19. This situation necessitates the insurance company needing a government subsidy to remain profitable. And the subsidy is going to be equal to the number of people in the pool times the absolute value of the profit. Now, we want it in millions of dollars, right? We're going to divide it by a million. So we're dividing by millions to put it in millions of dollars. And it says use 0 decimal places. So because that is a 2, we're going to leave that as a 0. All we have to do here is type 30. $30 million subsidy is needed to keep this insurance company from going out of business. Suppose insurance companies are free to charge different premiums to different risk pools, allowed to gather data on potential customers. Data like correlates of healthcare that include age, race, sex, location, body mass index, smoking status, etc., and are not forced to cover pre-existing conditions, and allowed to offer policies that appeal to high-risk Caucasians, like things like high price, low deductibles, low copays, and low-risk Caucasians, like low price, high deductible, catastrophic coverages. The choices its customers make reveal who they are. In this situation, the insurance company will be allowed to create policies for different risk profiles. If you end up being in a high-risk pool and your friend is in a low-risk pool and you talk, you're going to discover that this low-risk person is paying a much lower premium than you. So what you might want to do is you might want to tell the insurance company that you are a low-risk person. Now, the insurance company, if they can collect data on you, and you as a customer have to supply the insurance company with data so they can assess the probability of you using medical services. Maybe you take on a lot of risk. Maybe you jump out of airplanes with no parachute and you like to fly through the air, catch up with your buddy and grab onto him, and then he can pull his parachute. That's not ridiculous because Keanu Reeves did it in a movie called Point Blank in the 1990s. So suppose you're a risk taker like that. Well, the insurance company wants to find out if you are, or they want to find out your medical history. And so what they might do is they might say, well, in order to get this low risk premium, you have to supply us with all this information. They might scour your Facebook page, Instagram page, TikTok page to get an idea of who you are. Companies do that right now. Companies like Facebook, they have a pretty good idea what your politics are. You post pictures of your vehicles. You post pictures of your vacations. You post pictures of drinking micro beer at some niche microbrewery in Portland, Oregon, or you're drinking wine in Napa Valley. They can use all that information to figure out who you are, how much risk you're willing to take. Maybe there's a picture of you smoking a cigarette and you've told them you don't smoke cigarettes. So in order for you to get these low risk insurance policies, you would have to prove that you have a low probability of needing medical services. If insurance companies could do that, they could assess your risk profile. You, in fact, end up being low risk. They're okay with offering you this low risk health insurance policy. But if the information they analyze reveals that, man, the probability of this guy needing medical services is high because he has these risk factors. His mom and dad both died of cancer, or his mom and dad smoke, he probably smokes, et cetera, et cetera, et cetera. Then they're going to charge you a higher insurance premium. If insurance companies can do that and they charge a premium up to and including the most each segment's willing to pay, then everybody in Caucasia is going to insure. The company will sell 2 insurance policies that cost low risk Caucasians that amount, and high-risk Caucasians, that amount. All 56,000 low-risk Caucasians will insure, and all 39,000 high-risk Caucasians will insure. Now, the issue is, can insurance companies collect this kind of information? I think they can. Decades ago, they couldn't. And for that reason, because they couldn't find out who is in their pools and what probabilities they have for various medical services, they didn't have the information. That was called asymmetric information. But in today's world of electronic documents, medical records, etc., in today's world of information, if health insurance companies were allowed to ask their customers these kinds of questions in order for their customers to qualify for the low premium insurance policies, I'm sure they'd be able to get that information. A great example of that is car insurance. One problem with car insurance in the past is the car insurance companies had no idea what kind of driver you were in real time. They had your driving record, but they didn't know what kind of driver you were at the moment. Well, now they do. When people buy a brand new car, that car is linked to the internet through probably cell tower. That car has video cameras that's looking at speed limit signs. It has sensors on it that detect how close you follow the car in front of you. It senses how often you change lanes, whether you speed and zigzag through traffic. It's feeding this information into a big cloud of data. Car insurance companies want to buy it, and car companies that sold you the car, they want to sell it because it's an extra stream of revenue. So car insurance companies have been able to overcome asymmetric information. If medical insurance companies were allowed to collect that kind of information or ask you to justify that you are a low risk insurance policyholder so they can charge you a low premium, they could collect it. So I think in today's world, asymmetric information is not the issue that it used to be.